This is the second video of a series on simultaneous equations. In the first video, we looked at the graphical solution to a system of linear equations. Here are two equations, each with two variables. They are taken together, so that's a system of equations, and there is one single pair of values for x and y that satisfies both equations. That's the solution. When we had one equation with two variables, such as x plus y equals 4, the solution was the line here, shown in black. Every point on that line, and the line's infinite, is a solution to x plus y equals 4. So a single equation in two variables has an infinite set of possible pairs of values x and y that will satisfy the equation. So its solutions is an infinite set of points, the line, a line. The equation here, 2x plus y equals 8. That equation has a solution which is given by this line. This black line is all the points x and y that satisfy this equation. So it's an infinite set of points. So the line is the solution. The solution to the system of equations has to lie in both lines. It has to satisfy the first equation, so it has to lie in the first line. And it has to satisfy the second equation, so it has to lie in the second line. And there's only one point that does that, and it's the point of intersection 4, 0. So 4, 0 is the one point that lies in both lines. Therefore, it's the one point that satisfies both equations. Therefore, it's the only point which is a solution to this system of equations. It's the only point that will fit both equations. X being 4, y being 0 will satisfy the first equation because 4 plus 0 equals 4, and it will satisfy the second equation because 2 times 4 plus 0 does equal 8. So 4, 0 fits both equations. It satisfies both equations. It is the one solution to the system of equations. So that was the last video, the graphical solution. We're going to look at an algebraic method and use this as an introduction. So, solving this system of equations, we had the line x plus y equals 4 was a solution for the first equation, and the line 2x plus y equals 8 was a solution for the second equation, and the 1.40 satisfied both equations. It was on both lines. It was the point of intersection. Now I'm going to rearrange the first equation, x plus y equals 4, and I've rearranged it to y equals 4 minus x. The reason I've done that is, if we think of this black line, x plus y equals 4, any point on that line has, in general, the form x is the x coordinate and the y coordinate is 4 minus x. So this says y equals 4 minus x. The y coordinate equals 4 minus the x coordinate. So for example, here, at this position, the x coordinate is 1. The y coordinate is 4 minus 1, 3. If I move that to here, the x coordinate is 0. The y coordinate is 4 minus 0, 4. That's the point 0, 4. Here the x coordinate is negative 1. The y coordinate is 4 minus negative 1, that is 5. There it is, it's the point negative 1, 5. So every point in that line in general fits this description. X, 4 minus x. Now, the other line, 2x plus y equals 8, I'm going to rearrange it. There it is, y equals 8 minus 2x. The y coordinate is 8 minus 2x. It's 8 minus twice the x coordinate. So looking at this line, every point in this line fits this description. X coordinate's x and the y coordinate's 8 minus 2x. There it is, y equals 8 minus 2x. That's the y coordinate. So here, where x is 1, the y coordinate's 8 minus 2 times 1. That is, it's 6. So it's a point 1, 6. There it is 1, 6. Here, x is 0. So that's x is 0. The y coordinate's 8 minus 2 times 0. That is, it's 0, 8. If I was to pick somewhere else down here, x is 3. The y coordinate's 8 minus 2 times 3. Well, that's 8 minus 6, which is 2, and it is indeed y coordinate 2. So when x is 3, y works it out at 2 according to this general description. So this is for every single point in the line. It fits that general form. Every point on this line here, x plus y equals 4, it fitted this form. In general, I can have these 2 points having the same x coordinate. There it is. X coordinate 0, y coordinate 4 minus 0. That's the y coordinate 4. Here, with x being 0, the y coordinate's 8 minus 2 times 0, which is 8. And there it is, the y coordinate's 8. So these points at the moment have the same x coordinate, but they've got different y coordinates. There are again. They've got the same x coordinate 1, but the y coordinate's 4 minus 1, 3. Here, the y coordinate's 8 minus 2 times 1, 6. So that's the point 1, 3, and that's the point 1, 6. Same x coordinates, different y coordinates. I can even have them with the same y coordinate. So there they've got the same y coordinate, but as a result they've got different x coordinates. So they've both got y coordinate 4, but here the x coordinate's 0, and here the x coordinate's 2. There's only one place they can have the same x coordinate and y coordinate, and it's at the point of intersection, the point that lies in both lines. Now they've got the same x coordinate and they've got the same y coordinate. The x coordinate's 4, and the y coordinate here is 4 minus 4, which is 0. And here, again, the x coordinate's 4, and the y coordinate's 8 minus 2 times 4, which is 0. So x coordinate 4, y coordinate 0 for this one, x coordinate 4, y coordinate 0 for that one. That's the one place they have the same x and y coordinates. So at that one place, it must be true that 4 minus x and 8 minus 2x are equal to each other. In other words, if I take the two equations, y equals 4 minus x and y equals 8 minus 2x, they are in fact, at that position, that one position, they are equal. At the point of intersection, they're equal. The 4 minus x equals the 8 minus 2x. Now, solve that. Taking the minus 2x over to the other side, I've added in 2x to each side if you like. Or you can use change sign, minus 2x became plus 2x. That 4, it's a positive 4, plus 4 became a minus 4. Or you can think of it as add 2x to both sides and then take 4 off each side. Solves to x equals 4. Once you know x equals 4, well, it says y equals 4 minus x. Doesn't matter which equation I take. Just took the simplest there, y equals 4 minus x, and found x is 4. 4 minus 4 is 0. So x is 4, y is 0. What's happened is, here on the right, we've solved the system of equations by what we call substitution. If you look at this line here where it says y equals 4 minus x and y equals 8 minus 2x, this red 4 minus x is the y coordinate. It replaced that red y in the second equation, so it became 4 minus x equals 8 minus 2x. That 4 minus x substituted for that y, so this is called the substitution method. There it is there. Substitution method, because we made a substitution. We replaced this y, this red y, with this red expression 4 minus x. It's a substitution method. It doesn't require the graphs anymore. The graphs are gone. So we don't need the graphs. So in this method, it was based purely with algebra. That's the substitution method. I don't really need that up there. So this is the method. There's the system of equations. I've rearranged them so they both said y equals here. And I've replaced this red y by the 4 minus x from the first equation. And then I've got a simple equation to solve. It's only got one variable, x. And once I find out what x is, I can substitute back into one of these first equations and work out y. That's the substitution method. So it's algebraic, it's all algebra, it's all letters and numbers and manipulating them. Simultaneous equations, because equations are taken together. And it's a substitution method because I'm making a substitution. So from the graphical method, we've moved on to this algebraic method, the substitution method. So what we've done is you rearrange at least one of the equations to y equals. Doesn't have to be both. You substitute for y in the other equation using this rearranged form, and then you can work out x, you can solve it for x in other words, and you can substitute for x back in one of the initial equations and find y. So a rearrangement, substitution, solve the equation for x and take your x value and put it into one of the first equations to work out y. Now, having said we rearrange to y equals, sometimes it's easier to rearrange for x equals, and it works in exactly the same way. So although got here y equals, that's just the general way of doing it. It equally could have been rearranged to x equals, but when you do rearrange, if it comes up with fractions, just don't use that method. There'll be a later method called elimination in the next video. It'll be more useful. So if you're going to end up with fractions, it's better to use another method. So here's an example. 2x plus 3y equals 12, 2x plus y equals 8. Previously in the first video that was solved graphically. Now we're solving by substitution. What I've done here is rearrange the second equation, 2x plus y equals 8, to y equals 8 minus 2x. So that's the first two equations. This is the same two equations. So the first one's left alone. The second one's been rearranged. So it's the same pair of equations. Notice I've put a space there. Sometimes we put a line in just to make clear this is the same equations but rewritten. Notice that red y, that can be replaced by 8 minus 2x because it says here y equals 8 minus 2x. So that y can become 8 minus 2x. That's the substitution. So this is 2x plus 3, and then the y is replaced here. It's in red, but 8 minus 2x. It's bracketed because 3 multiplies everything in there, all of the 8 minus 2x. So that's a substitution. Break the brackets, 3x and 3 times minus 2x. And then just solve that equation. It says 2x minus 6x, that's negative 4x. That 24, take 24 away from the left and take 24 off the right. Or if you like, that goes over to become minus 24. Whatever method of solving these is up to you. There's different methods. You can use change sign, and so on. So negative 4x is negative 12x is 3. Now you know x is 3. It says there y equals 8 minus 2x. So just use that equation because it's nice and simple. You could use the other equation, 2x plus 3y equals 12, but that's more awkward. It's easy to get y using y equals. So replace the x by 3. It's 8 minus 2 times 3. And there's the solution. X is 3, y is 2. You can check the solution. You can put x to be 3 and y to be 2 in the first equation. That would be 2 3's plus 3 2's, and it makes 12. So you can substitute back to do a check. But that's basically the substitution method. We arrange one equation to y equals and replace the y in the first equation here by our new expression, and then it's just go on and solve. Here's another example. Taking this example because it's a wee bit more awkward because it says 3x minus y equals 4. So you're going to rearrange that. You've got to watch with that minus sign. So get a wee extra bit here. This is it rearranged to the side. 3x minus y equals 4. Took that minus y onto the other side to become plus y. And then took the 4 over to the other side to become minus 4. So the rearrangement is y equals 3x minus 4. So it's not take the 3x to the other side. You actually got to get a positive y. So I've switched the y. And then I switched the 4. And that gave me what y was. It was 3x minus 4. So you do what you did before. The y gets replaced by now 3x minus 4. So it's 3 bracket. This is important because it's a minus 3 here. You multiply by the brackets with a minus 3. You've got negative 3 times 3x. And you've got negative 3 times negative 4, making plus 12. That sign change is what you've got to watch. So, two things. It's got a minus y here. So you've got to be careful making that rearrangement. So it was really take the minus y onto the right and the 4 onto the left. And it rearranged to that. Make the substitution, make sure you bracket it. When you break the brackets, watch that minus sign. After that, it's 2x minus 9x, and it's take 12 off each side. That 12 is just going to cancel off with the 12 on the right. You get negative 7x is 0, so x is 0. Y equals 3x minus 4, and x is 0. 3 times 0 minus 4, y is minus 4. So there it is, x equals 0, y equals negative 4. Again, you can make x equals 0 and y equal -4 in the first equation, you'll get 2 nothings, and you'll get -3 times -4 is positive 12. So it will fit the first equation. So you can take your solution, go back to your first equations and put in the values for x and y and make sure it works. So that's the substitution method, and this time you have to watch the signs basically. That's why this example's there. It's because of that minus sign here, how to deal with it. And it's this minus sign outside the brackets, how it affects the signs in the brackets. Simply that these are careless mistakes that can be made and it can ruin the question because you ended up with awkward fractions as well as the wrong answer. Here's a third example. This is just to point out I wouldn't rearrange for y equals because I'd end up with fractions. If I was to rearrange for y, I would end up with y equals -1/2x plus 2. Don't want fractions. So here I would have rearranged for x equals. So took that plus 2y to the other side and made what x equals and just substitute for x. And that says 2x, that x is going to be replaced by 4 minus 2y. So there it is. Break the brackets, 2 4s, 2 times 2y, no problem with signs, it's a positive 2 outside the brackets. Minus 4y minus 3y, well that's -7y. And that 8, if you take it off the left, you take 8 off the right. Now, these questions will tend not to involve fractions, so if you come up with fractions, you've made a mistake in any of the worksheets that are made available. If you click the link in the description, you'll get access to the worksheets. This finishes off by this 7 being divided by that -7. So y is -1. Go back to x equals 4 minus 2y and make y -1. Very careful because this is minus 2 times -1, that is, it's subtract -2. So it's 4 subtract -2, that's the same as 4 plus 2. So the solution is 6 -1. To check it's right, I make x 6 here and y -1, that's 2 6's minus 3 times -1, it's 12 minus -3, that's the same as 12 plus 3, 15. x6 and y -1, that's 6 plus 2 times -1, that's 6 plus -2, which is indeed 4. So by substituting back into the original equations, you can check you've got the right solution. So you can substitute for x equals. You wouldn't do y here because you're going to get fractions and that would just be too difficult. If you click the link description, you'll get a worksheet. It's got heaps of questions. Simple ones at the start because the second equation is all y equals, so it's already rearranged for you. So the first 12 there are already rearranged to y equals. The next lot are rearranged to x equals. And then you've got to rearrange them yourself only for the last 6. And if 24 questions isn't enough, there's another worksheet. This is the worksheet for graphical solutions, but I just changed it to substitution method because you can solve them by substitution as well. With this minus y, they're a bit more difficult because you've got to watch the rearrangement. But in all of them, they'll have the answers with them. So if you click the link in the description, you'll get the worksheet. There it is. That's the exercise 1. That's where they're a wee bit simpler because they're already rearranged in most cases. That's the answers. I've given them as coordinates just because it was easier to type in. Then there's that slightly harder worksheet and that's got answers. And that's the substitution method. Clicking the link in the description, there's also a set of notes that accompany the videos. So this covers all simultaneous equations videos. So that was the straight line, the graphical solutions from the last video. This is the substitution method. So it's got an example there. Next video is the elimination method. Hope you found this video useful. Thank you.